Good morning, dear cadets. So yesterday I taught you the oxides of 16 group. So oxides of different members of 16 group I have explained you. And in sulfur case, two oxides were the most stable, SO2 and SO3. In SO2, oxidation state is +4. And what is their structure? Just see. The structure is like that. Okay. This is the structure. Generally we make structure like that. S double bond O, double bond O. Okay. So since this violate the, see, around the sulfur how many electrons are there? Around the sulfur 6 electrons are there. So just see, 2 electron here and 2, 2, 4 and 8. Okay. So this is the violation of octet rule, because around the sulfur how many electrons are there? Just see, 4, 4, 8, 10 electron is there. So this structure cannot be accepted. So this structure has been proposed. This one, first structure, second structure, and this is the resonance hybrid. Resonance hybrid. Okay. So just try to understand, in this structure what is there? See, 2, 4, 2 electron is shared, 6 electron. And here what is there? This is one type of coordinate bond. And I told you there is no difference in coordinate bond and covalent bond in modern chemistry. So rather than putting here coordinate bond, it is better to put single bond. Here positive sign, here negative sign. So it is understood this is coordinate bond. Okay. So here in this bond case, both electron is given by sulfur to oxygen. 2, 4, 6 and 2 electron. Okay. Now here just see. 2, 2, 4, 6. Everything is okay. Since sulfur is giving electrons, so positive, this is negative. Okay. So now here double bond is there. Next structure what we will do? We will put this electron this side. So here 2, 4, 6 is there. Same condition, negative and positive. Now here what is there? Double bond will come this side. Put this here. Okay. So resonance hybrid is like that only. Their structure is angular or bent. SO2 structure is angular or bent. The bond length between sulfur and oxygen is 118 picometer, but bond angle is 119.5 degree. Okay. So question arises here. Actually in SO2 case, bond angle should have been 120 degree. Bond angle should have been 120 degree. But there is a slight decrease, slight reduction from the stipulated bond angle, that is 120 degree. So the explanation of reduction of bond angle from 120 degree to 119.5 degree in the structure of SO2. So what is the explanation? Explanation is due to repulsion between lone pair and bond pair electron, the bond angle of SO2 is reduced from 120 degree to 119.5 degree. Just try to understand here. This is the lone pair and this is the bond pair. Already I taught you that because of bond pair repulsion, there is a elongation of bond angle. But due to lone pair and bond pair repulsion, there is a shrinking of bond angle. So here this lone pair and this bond pair, they will repel. What is here? Here BP, bond pair electron is there. This is repulsion. So because of repulsion between lone pair and bond pair, there is a little bit shrinkage in the bond angle. So the actual bond angle is 119.5 degree rather than 120 degree. So this is the resonating structure of SO2 and bond angle. Actually, how SO2 molecules is formed? So SO2 molecules is having covalent bond. How many total bonds are there here? 4 bonds are there. So I have to explain how the 4 bonds are there, how oxygen and sulfur overlap with each other and form that one. And this structure is very, very important. Sometime they ask what is the structure of SO2, how you will explain the structure of SO3. So don't worry, their structure is also very easy and you will come to know. So dear cadet, just see the structure of SO2, okay, on the basis of overlapping concept. So one more thing I would like to clear here. In modern ABC, they have explained wrongly the structure of SO2. Be careful. Okay, now I read from other book and I am explaining. Just see, in SO2 the sulfur hybridization state is sp2. The ground state electronic configuration is like that: first s2, 2s2, 2p6, 3s2, 3p4. So this is 3s2, this is 3p4. Now in excited state, what is there? One electron of this one. Here only you make right now 3, 1, 2, 3, 4, 5. This is vacant. Okay, what is this one? Vacant. In ground state. Excited state, one electron of 3px will jump and will go to here. Just see, I made this one. Here I wrote 3s2, here 3p3. One electron of this one will go here in 3d1. This is sp2 hybridization. And now just see, who is overlapping atom here? Oxygen. Two oxygen atom overlap with the sp2 hybridized orbital of sulfur. So oxygen electronic configuration is first s2, 2s2, 2p4. Okay, this is there. Just see, here I make, this is 2s2, this is first s2, this is 2s2, this is 2p4. Now how many oxygen atom is involved in the overlapping? Just pay attention. One oxygen, second oxygen. Now in between I made here sulfur. So just see, sulfur I am writing 3s2, 3p3 and 1 3d here. Now in oxygen what is there? The unpaired electron is there in px and py. What is there? In px paired electron, py and pz. So just see, this sulfur is having 4 unpaired electron. How many unpaired electron in excited state? 1, 2, 3, 4. Now here oxygen is having 2 unpaired electron. How many oxygen atom is involved? 2 oxygen atom. So just see, this one will make bond overlap with this oxygen atom, this oxygen electron. Okay, 1, 2, 3, 1, 2, 3. So this and this they will overlap and they will form p-pi bonding. This sulfur atom, this sulfur electron will overlap with this oxygen electron and again it will form p-pi and this will also form p-pi only, this 2 electron. Okay, now 1 electron of oxygen will overlap with the 3d1 electron, that is p-pi d-pi bonding. What is this one? P-pi d-pi overlapping or bonding. So now we have got the clear cut structure of sulfur. Just see, yes, double bond O, double bond O. Here oxygen 2 lone pair, here oxygen 2 lone pair. Oxygen lone pair is this one, first s2 and 2s2. They will be as a lone pair, not first s, sorry. 2s 1 electron and 2px 1 lone pair will be here. This is 2px 1 lone pair. So 2 lone pair is there. One is 2s and another one is 2px. Same is the case with this sulfur. This oxygen. Now what about sulfur? Sulfur 1 lone pair is there. This lone pair, this is 3s2. So this is the sulfur lone pair here. Now just see, here what is there? 4 bonds is there. Out of 4 bond, this one, sigma bond. Another one is pi bond. These 2 are pi bond. So in pi bond what is there? Just see. See, 1, 2, 3. Now just see. Out of 3 means 4 bond, one is, another one is p-pi only. This is only p-pi d-pi bond. One bond is p-pi d-pi bond. Rest other one is, this one is a p-pi bond. Okay, and these 2 are sigma bond. First 2 bonds are sigma bond. So now just try to understand here. Just you mention 2 p-pi bond. Don't mention this one p-pi bond. This is sigma bond. Okay, this is sigma bond and one more sigma bond you can make. Only 2 p-pi bond. This is also sigma bond. So these 2 are, this one and this one is a p pi d pi bond. So this is one is p pi, just see, this is p pi, this one is a p pi d pi bond. This is the complete structure. Okay, always remember sigma bond. When sigma bond is formed, sigma bond is formed when pz orbital overlap. Okay, here px is not overlapping, just see, because in oxygen px is paired electron. Now this x electron of sulfur will overlap with y. So of course, just remember, if z is there, z overlapping is there, so that must be the sigma. Now in absence of z, px will form the sigma bond, but here z is present, so px or px p pi, they will overlap and they will form the pi bond. So just try to understand, this sigma bond is here, this sigma bond, two sigma bond is here. So one is the sulfur pz, another one is oxygen pz. Similarly another one is here oxygen, two oxygen is there na, so the pz of oxygen, and here what is there, sulfur, they will also form the sigma bond. Now remaining one, they will form the pi bond. So out of two pi bond, one is p pi, another one is a p pi d pi. So this is the complete structure of SO2. In the same way we can explain the structure of SO3 also, but remember in modern ABC their explanation is wrong. Be very careful. Okay, this is the complete structure. Only one p pi is there, another one is p pi d pi. Okay, this is one more thing is there. After hybridization, what is there? No one is p1, no one is pz. That is why anyone you can make here sigma bond, anyone you can make here p pi bond. Always remember, because after the hybridization, no one is px, means orbital lose their individual identity. Okay, so we can't say, in oxygen case we can say that this is p by, this is pz, but in sulfur case we can't say which one is a p by, which one is a pz. Always remember, because sulfur has undergone sp2 hybridization. So I hope that you have got, just zoom it and see properly, definitely you will understand. This is the important thing. And for the formation of sulfur, just sulfur trioxide SO3, everything will be same, only the number of oxygen will be 3, and this 3s2 electron will jump from here and will go here. Means what is there, number of unpaired electron 1 2 3 4 5. Just wait, I will explain that one also. Just see the dear cadets, structure of SO3. Just will make the structure. Just see structure of SO3. This is trigonal planar. What is this one? Trigonal planar. The oxidation state of sulfur is +6 here. Resonating structures are like that. Just see here 2 4 6. How many bonds are there? 6 bond is there. So try to understand, according to this structure, around the sulfur how many electrons are there? 12 electrons. 4 8 12 electrons. That is the violation of octet rule. Means this structure is not correct. So resonating structure came into light. Just see what is proposed, that between one sulfur and out of 3 in one oxygen, between sulfur and 1 out of 3 any one of oxygen, coordinate bond is there. Okay, now it is correct only. Just see 2 4 6, correct. This is 4 8 electron, 2 electrons sulfur will give to this one, so the octet of this oxygen will also completed. So now since sulfur is giving the pair of electron, coordinate bond, so the positive sign here, negative sign. Okay, so this is the structure. Now this is accordance with the octet rule. Now shift this electron here, shift this electron here. So this bond should, means out of 3, 1 oxygen definitely will have coordinate bond only. Second, and this one is what is this one? This is 2, this. Okay, so this is the third, this is the third one structure, this is the fourth one structure. Just see, now this negative sign one by one has been delocalized to all the 3 oxygen. So now this is resonance hybrid. What is this one? Resonance hybrid. Okay, And now to explain their structure, just what I will do, just see. Sulfur 16 is there. So in ground state, what is there? Ground state, first S2, 2S2, 2P6, 3S2, 3P4, 3D0. Okay, 3D0. So now here what is there? This is sulfur. This is 1, 2, 3. Here what is there? 1, 2, 3, 4, 5. So what is here? 3S. Here what is there? 1, 2, 3, 4. Now here what is there? The D is 0. This is in ground state. Now sulfur 16. ES. What is this one? Now I will not write first S and 2S and 2P. That much I will not write. B require only that much. So 3S. Now 1, 2, 3. 1, 2, 3, 4, 5. Okay. So now here what is there? This one is there. Now this is there. Here this and this. And here what is there? Here right now excited state will bring. So the one electron from here will go here. Okay. This is 3p. Now similarly one electron from here will go here. Okay. So just see 1, 2, 3, 4, 5, 6, 7. 6 electrons are there, not 7 electrons. 6 unpaired electron is present. 2 3D orbital is involved here. And what kind of hybridization would be there? We'll tell you that one also. What is the hybridization state of sulfur here? We'll explain. So right now what is there? This is the excited state of sulfur. Okay, I will rub this side and we'll explain. Just see here, dear cadets. The hybridization state is sp2 only. Just see. sp2. 2p orbital, 1s orbital. 1, 2, 3, these are unhybridized. So these three means sp2 hybridized orbital, they will overlap with the oxygen unpaired electron, that is py and pz of oxygen. Okay. So just see, they will form sigma bond. Only these three will form the pi bond. So out of 3 unpaired electron, one will form the p pi, another 2 will form p pi d pi. Just wait, I will explain. Just you write here sulfur 16, correct? Only just write that one. 1, 2, 3 p and this 5d orbital. Okay, this is sulfur. So here how many electron? 1, 1, 1, correct? sp2 hybridization. Now here 1 electron, here 1 electron, here 1 electron. Okay, now this is sp2 hybridized. Just see, sp2 hybridized. Now just see how many oxygen you should write? 3 oxygen. So oxygen electronic configuration you know. So we'll write only which is required. So oxygen 2s2 and 2p4. So this is 2s. Don't write 2s also. This is, write down here oxygen 8. Here equal sign. Here just see 2 this. This is 2p4. Okay. Now here also what is there? Oxygen 8. Now here what is there? Here also just write 1, 2, 3. So what is this one? This and this. Here also what is there? Write one more oxygen. Oxygen 8. Just write here 1, 2, 3. So just see 2 electron, here 1 electron, here 1 electron. Correct? So 3 oxygen I wrote. 1 oxygen, just see. 1 oxygen, second oxygen and third oxygen. This is O8. Okay. 2p4. Here also write 2p4. Here also write 2p4. 2p4. Upper side I am writing 2p4. Now just see. This electron, this is px, this is py, this is pz. Here also this is px, this is Py, this is Pz. Here also Px, this is Py, this is Pz. Now just try to understand. Pz, this unpaired electron, just see, this is this one and this one, sigma bond, okay. This one and this one, what is this one? This is also sigma bond, okay, no problem. Now oxygen, this, take this oxygen, you can take, okay. Now this oxygen and this oxygen, this is also sigma bond only. What is this one? Here sigma, here sigma, this is also sigma. Now just see, how many are left? Just see, this one and this one overlap. This one, 1, 2, 3. This one, yes, this one and this one, they will overlap, but they will form now. This is P pi, okay. Now this one, this and this one, this is P pi D pi, okay. Now this one and this one, this is P pi D pi bonding. So just see. Now I will make structure here SO3. Just see. Yes, double bond O, single bond O. Here 2, 4, 6. Correct? So just see. This is sigma, this is sigma. Okay. Now this is P pi. Okay. P pi. What about this one? This is also P pi. This is P pi D pi. This is also, you can put here double bond, there is no problem, just for the explanation. This is also P pi D pi. Okay. So try to understand here. 1, 2, 3. This is sigma bond. 3 sigma bond is there. Just see. 1, 2, 3 sigma bond. And one is P pi, another one is P pi D pi. Just check this one. So this is the complete structure. 2 P pi D pi bond. In case of SO2, what was there? SO2 structure was like that. Yes, double bond O. So sp2 hybridization means 2 sigma bond. Now 2 pi bond is there. So out of 2 P pi, one is P pi, another one is P pi D pi bond. So in case of SO2, only one P pi D pi bonding is there. In case of SO3, 2 P pi D pi bonding is there. Okay. Here 2 sigma bond, here 3 sigma bond. Okay. That is the difference. Okay. So I hope that you have got. These structures are not complicated. Just you do one thing. Just first you make the hybridization state of sulfur and write down the 2, 3 overlapping oxygen atom to P4 orbitals and keep on overlapping. These sign indicate overlapping. This one and this one and that one. They are indicating just overlapping. What does it mean? That they are overlapping together. It doesn't mean that you should overlap this one with this one. But you can overlap with this one, no problem at all. You can overlap this one with this one. I don't have any problem. But what is their overall structure should be same only. Means in SO3, 3 sigma bond should be there, 3 pi bond should be there. Out of 3 P pi bond, one is P pi, another 2 are P pi D pi bond. Okay. So I hope that you have got this one. Just be very careful. So ultimately we came to conclusion that SO3 is having trigonal planar structure. What kind of structure? Trigonal planar structure. Bond length is 143 picometer. Since in sulfur is not having any lone pair, so its bond angle is stipulated 120 degree. There is no reduction. In case of SO2, there is a reduction of 0.5. due to lone pair bond pair repulsion. Some other information related with the SO3 are as follows. Gaseous state, In gaseous state, SO3 molecules is found in discrete state. What is the meaning of discrete? This is only individual SO3 molecules, okay? But in solid state, it is found in polymeric chain or cyclic structure. Polymeric chain. This is the polymeric chain. Just see. Keep on adding this side and this side. This is the polymeric chain structure. SO3. SOO3 like that. SOO3. This is the polymeric chain structure, and this is the cyclic structure. What is this one? Cyclic structure. Okay, no problem at all. This is the cyclic structure. Cycle, just see, very easily you can make. With one sulfur, 2 double bonded oxygen, and between 2 sulfur, 1 oxygen. Just see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the cyclic structure. There should not be direct bonding of sulfur and sulfur. There should not be direct bonding of oxygen and oxygen. Between 2 sulfur, 1 oxygen, and between 1 oxygen, 2 sulfur. Just see. Between, just see. Here, sulfur, oxygen. Sulfur, oxygen. Sulfur, oxygen. Means between 2 sulfur, 1 oxygen should be there. Okay. So this is all about the oxides of sulfur. That is SO2 and SO3. Over. Others are also forming the oxide like SeO2. So SeO2 structure is just like a SO2 structure only. SeO2 structure is this one. Se double bond O. This is SoEO2. Now tellurium oxide is also there. TeO2. So same way TeO2 is also formed. But the most important one is SO2 and SO3. As far as SeO3 is concerned, same way you can make SeO3. So their structure is like that. Se double bond O, just like SO3. So in this way the oxides of 16 group is completely completed. Now let us move to the halides. See the halides of 16 group. So these are the halides of 16 group. Just see. Here I wrote the 16th group member: oxygen, sulfur, selenium, tellurium and polonium. This side what is there? Halides: fluorine, chlorine, bromine, iodine. See, oxygen is forming 2 fluoro compound, O2F2, OF2. Sulfur, many are there, but basically these are the 2 popular one: SF4, SF6. Selenium, SeF4, SeF6. Tellurium, TeF4, TeF6. Okay. Now polonium is not forming with the fluorine. Chlorine, just see, ClO2, Cl2O6, Cl2O7. Okay. With the bromine, what is there? BrO, Br2O3, Br2O5. Now chlorine with the sulfur, SCl2, SCl4. Now with bromine, SBr, SBr4. Chlorine, SeCl2, SeCl4. Here SeBr4. Okay. Now here TeF2, already I told, TeCl2, TeCl4, TeBr4, TeBr2. Here with the iodine, TeI4. Here PoCl2, PoCl4, PoBr2, PoBr4, PoI. Okay, these are the halides. So if you see carefully here, so the fluorine is the only element. Fluorine is the only element which is forming compound with every member except polonium. Means what is there? SFC. SF4 is also known, SF6 is also known. Okay. But SBr6 is not known. Okay. Just see. SeBr6 is also not known. Tellurium, this is also not known. Polonium Br6 is also not known. Okay. So these are the question. Bromine iodine compound is not there. Even only chlorine is also not there. Only the fluorine compound is the highest oxidation state. Just see. SF4. SF6, that is there. Just see here also, TeF4, TeF6, these are, SF6 is known, SECF6 is known, TeF6 is known, but SBr6 is not known, SEBr6 is not known, TeBr6 is not known. This is the question. So very simple answer is there. Just see, fluorine size is small and oxidizing character is very strong. So 6 fluorine atom can be accommodated around the sulfur atom, selenium atom and tellurium atom. Okay. But big size bromine atom and iodine atom cannot be accommodated around the sulfur, selenium and tellurium. That is why SF6 is known, but SF6 is known, but Si6 or SBr6 is not known. Okay. So now almost today's duration is over. Tomorrow we'll discuss so many questions related with these things. Okay. Thank you.